What is going on, everyone? Today I want to share and react to Ron's Fairfield County Signature build using a Ceriatone chassis. Now on the screen right now you can see the Ceriatone chassis and the layout of that, but using my circuit board inside and my Fairfield County Signature faceplates. So it is a little different than my original, and here's just for comparison, here's my Fairfield County Signature in the Amplified Nation chassis. And I actually had to stop selling these faceplates because Two Rock's lawyers came after me and said this looked a little too close to theirs, especially when I added blue signature using my own autograph. And I was happy to apply and oblige. So I came up with this new design here for the Ceriatone chassis. A couple of things I love about the Ceriatone chassis and going that direction is on the back, you're going to notice that there's a lot of cool options that is not available on the actual original Two Rock amp. And that's a half power switch and this impedance selection, which allows you to add a external speaker pretty easily, and then just have an extra cab or whatever you want to do there. It's very cool, and plus the bias is a lot easier using the Ceriatone chassis. So today I want to react and kind of go through, and this is highly educational, and one of my favorite parts about seeing other people build using my circuit boards or participating is that they really become a coworker of mine. Ron was able to spot a few things that I didn't catch the first time around, and it helps everyone that's building this project get a little bit better and offer that feedback. So I want to share all the cool things, and in the description I'll share his link. He was able, and very happy to let us check out the high resolution photos. So I'm going to kind of go through from the beginning to end of his build, and I think there's a tiny tone clip at the end, maybe. Don't quote me on that just yet. Really cool thing about Google Photos is that as Ron was adding photos in basically real time, anytime he was working on it, he uploaded photos. We were able to comment, and not only me, but anyone that was following along. You see that there's a few folks here that was following along with his build and chimed in. So on a particular photo, you're able to chime in, ask some questions with the builder. Super cool, and if anyone else is building an amp or a pedal or something, share out that Google Photos to everyone. They can follow along, maybe grab some tips and tricks, because I always learn something new when I follow along with someone else's build. So let's get into it. It looks like Ron organized this album using some of my my diagrams right here. He added his own diagram from my site. Very good, probably easy resource. And here is just a general inspiration of the real John Mayer signature from Two Rock, and here's the guts of it. So it looks like he had his cab made from Ceriatone, which I do recommend. So you don't have to piece it together. They already know what they're doing. The quality of it looks great. Nice and tight front panel here. That's usually the hardest thing to do. And the transformers he's using, I believe, are the Habor ones that I sort of added in my bomb. I did add in my bomb. It looks like he made his own, which is super cool. He made his own amp stand, and I love that. Real do-it-yourself type of approach on this one. This is the solder that I loved. It's got such a low temperature. Everything kind of solders really nicely. It makes it really easy for folks to solder. He got the quarter pound. If you go for the full pound, it's like $100. But it's going to last you, like me, I have gone maybe 2 years now with that, and I build constantly. It's really cool what he did here, and I'm going to definitely do it next time, is that he added, I don't know what these are, but they're going to make space between the circuit board and the resistor itself, so it floats. If you follow along any Amp Tech builder pages, especially with Hot Rod Deluxes, if this resistor gets too hot, it will start burning basically the board that's above it or below it. So making a little bit of a distance between that creates an air gap, and for air to that heat to dissipate and not just burn up that board. So I love that he did that. When he soldered in the capacitors, he added this foam. Pretty cool idea. I didn't do that the first time. He's using these awesome, I love these PCB holders. And that's in my description as well. I want to go back to this photo real quick. Not this one, the next one. And the solder that he's using is that, again, this lower temperature, the flux in it is inert. So that means it doesn't really need to be cleaned, but it looks like he might have cleaned it. But look how the solder comes through. It's just the right amount. So this is more or less what you're looking for. It's just a little bit coming up. There's not too little. So you see like kind of a hole in here. It is coming up through. So he did solder on the other side, which is the top of the board. You can see here. So he's soldered in and then cut the leads flush. He might have even gone over with the soldering iron again just to round out the top of that. But that looks like just the right amount of solder. This is the power filter section. Kind of gonna run through here. The bias checks, these look great. These banana jacks are very easy to check the bias. Right, that is not what I need right now. As we go down, Ron did the outer foil. So he took the time and did the outer foil. And you can see here that my original circuit board has this lead, but that's wrong. So Ron was good. He read through my blog post, and you can see here that the leg should actually be extended. Very cool. He's using the Coasphere resistors that I spec'd out for this build and the BC capacitors. All top-notch stuff. I'm sure it's going to sound great. One thing I do want to note here is that one of the builders, I believe it's Matt, reached out to me and says, hey, this resistor feels too small in this spot. Well, according to the specs, it should be good. I did change afterwards this resistor to something a little physically bigger, but there is no concern, but it is something to keep an eye on. Just in case that resistor, you're having something funky go on, I would check this resistor if you use that one. I'd spec'd out a larger one on the next one. But I think Ron's going to be okay. He has played the amp for many hours, he said, and hasn't had an issue. So that's good. Standard, all these resistors are in the Mauser BOM on the Mauser page. So that's cool. He spec'd out and looks like 261K for the high, and then he measured everything else, which is great because you should know what you're using in here. And I love that he's using the dress nuts. So he's really taking his time doing it right. It looks great. I can't wait to show you this next thing. So look how precise these hooks are for the bus wire for the ground. He did such a good job with this, and something that I'm gonna just have to do next time to step up my builds so they can be more like Ron's. It's super cool how he did that. Looks great. A cool thing about the Ceriatone chassis is that rainbow zinc. Every place of it is conductive, and the coating that they put on it to give it that rainbow color is actually a barrier against oxidation from the atmosphere. So besides it looking good, it actually is functional. I do want to go back, see if I can find a picture of it. Here it is. For the transformers, Ron had to open up the basically where the transformer comes up and through, and the only reason for that is because the housing on the top of the transformer is bigger than the Ceriatone. Actually, the Ceriatone transformers don't even have a top to them. And what I've done in my Steel Strand Singer number 2 is I've actually removed that top from my classic tone transformer. And that way it just fit right up there. But this transformer, if you want to keep that top on, you have to take a grinder and open that hole just a little bit. Again, that's only on the Ceriatone chassis. The Amplified Nation one seemed pretty okay without it. Let's keep going down the line here. Really kind of cool. The setup, it looks like the capacitor for the reverb, he kind of flipped it up, which is cool. It's like kind of hidden and out of the way. One big advantage, and I'm going to show you and illustrate it here. Ooh, it's upside down. One advantage that I feel like is pretty good using the Ceriatone as well, tone-wise, and well, actually noise-wise, is if you look at the 2-rock, we have the gain and the master all the way to the right. And if you look at the inside of this chassis, see these right here? That's the diodes for rectification. And there is noise that's being radiated from that. And it does, and it will, and it could, I guess, bleed into the gain, because that gain connects directly to the very, very sensitive V1 tube. I believe. It's been a bit. Let's see on this diagram. Gain, yep. So it goes all the way back to this V1 tube. This is very, very sensitive to noise. And you can see here that the wire is staying probably as short as it can be. But on the 2-rock, it needs to travel all this way, and it's, see this white wire? That's going all the way back to right over here. It is, and it will pick up noise if you're not careful with your wiring. Doing it with the Ceriatone chassis, you're just making that small run to the front, and you're staying away from any of the power, any of the radiation that's coming from these diodes. And plus the diodes that I choose are high-speed diodes, and they don't radiate as much. So you're actually dual benefit by going with my part selection. Some people do say that diodes and rectification matters. What diodes you use? I don't know. I think making DC is DC, but I could be proven wrong. Some people say they hear a difference on the rectification diodes. You would definitely have a different feel if it was tube rectification. So I don't know. Let's get back to it. This is a pretty cool way. He's kind of taken some artistic license here. Establishing, I believe this is the deep switch, and how to do that. I really do like the Ceriatone chassis layout. 2-rock is great. You can see that here, and my illegal faceplate. And that's fine. It looks cool, like the original, but just the Ceriatone's way more functional. All right, let's see, what else can we learn? That's the input. He's doing a great job. Looks like he's using some nice wire. I believe this is the RG188 silver wire that I found on eBay. So he follows along. That's awesome. Here's the transformers. Oh, where's the one picture that I saw? Okay, here it is. So the transformers from Classic Tone back in the day actually extended down, and this leg was a lot lower. What Ron has done to adapt these, to basically give some lift to these transformers, is add some nuts in between it looks like a washer, which makes sense, maybe a lock washer, between those feet and the chassis. But the Classic Tone used to extend down here. They don't, because they're out of business. So we have to find alternatives and alternative ways to adapt. Looks like it was relatively easy for him, so that's pretty cool. And it's safer because, as you can tell, there are some screws that go directly underneath, and that would not be flush to the chassis at all. He's using Belton tube sockets, which I think are the best ones out there. All right, he's even taken some extra beauty shots of his Belton tube sockets. All right, so here's something that I wish I did, and I think maybe because he saw my frustration, he adapted and really focused on making his own attempt at making it better. And I think what he's done is really come up with a slick solution. So what I did on mine is I made one big, huge braided twist, and then I would cut it and then unravel and then connect it to the tube socket where I needed to directly in the chassis. What Ron has done is actually kind of measure and twist to length. And here is the result. It is slick. It looks great. It's really well done. And also I like what he did here. I don't know if this is maybe one of the wires or he extended his own wire over here, but I strongly dislike doing heater wire, and a lot of people will also agree with me. Especially kind of jumping over here, those two pins together. So that's what, 1, 2, 3, 4, and 5. Pins 4 and 5. And Ron's done such a good job of tucking those in. And that's exactly how 2Rock did it too. So he's got the resistor here going to the LED just to slow that current down a bit. Since the transformers do not have a center tap for ground, you have to make an artificial center tap, and you do that using 100 ohm resistors. It does add a little bit of extra current to the transformer and those filaments, but the transformers are fine. They can handle that. You can see them tucked underneath. Here, there's not really a chance of failure, but if something did go astray, look for those with your heaters. If something's not working in your heaters, check those resistors out. He's done a great job here too. I like what he's done. Taking this shield ground on the coax, and I think he's using actually donated stripped wire that way. And another thing I like about this coax is it's high heat, so that kind of shield or that sheath or whatever you want to call it is high temp. It's not going to melt, or less likely going to melt. So he's gonna go ahead and moving ahead with these things. He's using the DMT, which are perfectly fine. They're actually a pretty solid alternative to the JB local negative feedback capacitors that are used on the original. They're kind of hard to get. Usually they're like NTE JBs. They're hard, but these are great. Don't worry about it. Just get with the DMT ones. I think they're Yeah, DMT. I think of Joe Rogan when I say DMT. And in his podcast, you see here the impedance selection, the effects, send and return. I don't know why they're backwards. I feel like you want like the send to be over here and then returned. But hey, this is kind of like how 2Rock did it, so whatever. These are cool. I started using these a lot because they're tight tolerance, and I kind of wanted the power section to be really tight tolerance. And these are wire wound 5-watt resistors. They're a little bit lighter than you normally see the square, and I think we can see them up here in this build. They're normally like square resistors. That's the kind of like the coating on them, or the heat dissipation is using the cement. And then instead, and there's the local negative feedback ones that I was telling you about earlier, the NTEs. And then these are a little bit smaller, a little bit lighter. It looks like he's got a lead forming bendy thing that he's built himself. Again, like this, I'm so proud to show you guys this, and so happy that he was happy to share this album to the world. Looks like he's doing some cool things in here. He's documenting his ground straight. You want this to be an isolated for code. You want it to be straight to the chassis, nothing else touching on this. That's code. We did learn that the Carling switches, I thought this was going to be a good one for a half power switch. With my wire, and it is a good switch for half power wiring, but the problem on my diagram was for a traditional or more common double pull, double throw. But it turns out the Carling is sort of opposite. So when you turn the bat to the right, on the backside is making a connection on that same side of the bat, the direction you're pulling it. So he discovered that, and I did end up making a change on my layout, but later reversed it when another builder of mine reached out and says, hey, check out these NKK switches, and they feel solid. So I'm now replaced these Carling switches with those NKKs. Ron can go back and change that if he wants. I think all he did was just reverse the wires and was on his way. The way these switches right here are the ones that were used on the original two-rock. So they feel like if you were playing the two-rock of the day. This is pretty cool. So this switch specifically in this capacitor is for the noise pop when you come off of standby. So that's going to prevent the noise pop, kind of flyback voltages and all that crap. Here's the rectifier network over here. You can see that on my circuit board it's 2 millimeters thick, and look how thick these wires are. It's basically point to point, if not more surface area for electrons to flow. Very, very clean. It is easier, and you will probably find that you're going to lock in the power supply first board before the preamp. So it's obvious that he's doing that. Oh, excuse me. Taping down the wires is definitely a good idea. It's cool. He's using, I believe these are the silver grade wires, which is rumored to be the same exact ones that are used on the original two-rock. Here's my warning if anyone's found these. Basically, this amp build does contain high voltage. Double check all your stuff. Whatever you read online, just do your own research and validate those claims before you just pop in and say, well, this guy told me to lick this resistor while it's in the circuit and plugged in. Don't do it. Use your common sense. If it says don't do it, don't do it. Here's the resistor. Oh, I love these Koa spears. I just love that color. Resistor going to ground. That's going to create basically the tail resistor, as they call it, on that bias pot. What else can we talk about? Okay, here's a good shot. I was about to talk about this. Using Ohm's law, these are basically bias taps. Normal way to find out where your bias is or how much bias on your tubes, it's measured in milliamps. And one cheesy way, some people call it cheesy, whatever, to use a regular voltmeter without pulling out your tubes to insert this thing, because basically to figure out amperage on your tubes, to figure out bias and stuff, you need to take out the tube, put this device in the middle that will intercept the current and put it through the multimeter and then back into the tube, and then you measure your current that way. Using the 1 ohm method, you're using Ohm's law to calculate and translate milliamps into millivolts. And the great thing about millivolts is that you do not have to break the connection through the network and circuit to measure it. You can just measure it in line. So these banana jacks on the other side, you just touch your probe in and you get a few millivolts, and that's equivalent to the milliamps version of it. So this is really clean. I love what Ron did here. Very, very symmetrical, and I appreciate that. It feels good looking at it. So if it feels good looking at it, then it must be good. This hole here is interesting. I believe it is simply just to, and I don't know if there's a quick picture of the back. This hole here, you can put a screw through it. You can put a plug in it. Since there's nothing, oh, here it is. Right here, he's got it. Since there's nothing sort of close to the back that's a knob or a switch, I guess you could put switches in there for if you want to play with local negative feedback. Holding that back plate into the chassis, it could flop around. So you just simply, there's a hole for it. You simply add a screw with a nut on the back end. He's using nylock washers, which I've gone through the whole stages of, all right, these are a good idea. Oh no, these are a bad idea because of heat. And then I've gone back to, oh no, these are a good idea. Because I normally would also use the Keps nuts. So that has the washer that's kind of pressed in, right, to the nut, and it would hold it in place. But then I started reading again, because the internet, of course, you keep on reading things on the internet. And I'm continuously trying to improve my designs. As I've read, well, actually, nylock is best for vibrations, because even if it does come loose off one of these connections or whatever, off the screw, even if it does come loose, it needs even more, basically it needs to come off, and using that nylock, it's going to not free spin at all until it's completely backed itself off. And the chances of that backing itself off is a lot less, even under heat, than even the Keps nuts. Because the Keps nuts, you crank it down, whatever, and then it takes a while to back off initially. But then once it's off the kind of base, it's going to free spin. Nylock does not free spin until it's completely out. So it dramatically reduces the chance of backing itself all the way out and creating arcs inside your amps and things like that. So highly recommended using nylocks now. I get goosebumps looking at this picture right here, because Ron has his homemade amp cradle and the amp looks like it's ready to go. A cool design aesthetic is the LED is a lot smaller. It looks cool. You got the standby and on cables in the front, so you don't need to reach around your amp in the back. And I don't know if anyone else has done this, but it kind of gets a little scary in there. And if you have an amp wall like I do, first world problems, that could be an issue. So it looks like he's doing final assembly. How exciting. I believe this is the tool that he's going to use as a chopstick to poke around. You can do video. I wonder what he's doing here. Oh, he's just doing a video flyby. How cool. And then also, by the way, as he's uploading, him and I are basically going back and forth on the chat of all his photos. Yeah, like, thanks, Ryan, comments in the heater. So anytime you had a question, we were there, right there, answering it. Here's the Carling switch. It's cool. So you can see, like, in real time, everything that he's going down in the conversation that we had. And he's given suggestions if he's lost with resources or something. We found it. It's really cool. I love this picture of Ron. He's really diving in there. It looks like he's checking the bias voltage. I wonder who's taking the picture. I bet you it's his significant other. This might be his first time turning it on. Yeah, so he's going to flip it for the first time. He's got his thing over here. There he goes. And that's what you do. If you don't have a current limiter, you bring up the voltage very slowly. Actually, looks like he's using both. All the connections in the middle. I would have, he's got the master down, gain down. So that way it's not, if it does turn on, it's going to pop in your face with loudness, hopefully not with anything else. Great tubes. I love these, the black plate 6L6s. And then he's got and that's actually pretty similar to the original. There's his red base, black plate version. And then these tubes, they weren't red plate back in the day, but these are very similar construction to the ones that came with the 2-rock, the one of the 25. So it looks like he's got this thing pretty well buttoned up at this point. I love that he did a chart for his voltages. These look a little low, but his bias might be a little hot too. Oh, no, he's got his bias right here. Those kind of look pretty good. Yeah. So if you use the Ceriatone power transformer, it is going to bring up your voltage a little bit, maybe around 440. It's really depending. I like how he's measured the wall voltage, because that does matter for the everything else kind of exponentially will start going up, especially on your secondaries. Another thing I think, the other thing I do like about the Ceriatone chassis is on the back, you'll see it, is you got the fuse for the high tension line. That's what HT stands for. I got a few questions about that. HT is the high tension or the secondary on the basically the main input coming into the amp. And then you have your mains fuse. So the mains fuse is from the AC coming to your amp. Boom, boom, boom. So it's a fail-safe to anything that fails that's not part of the high tension fuse. So the high tension fuse is if it's going to save your amp if you have something on the high voltage line that just dies, or there's a wire that's just found its way somehow in your amp. It's going to dump all of that to your center tap of your high tension line, and the fuse hopefully is going to save your amp from a bigger problem than what it should be. All right, so here he's got his transformer, which has its own fuse, which is cool. So he's measuring his power, energy, and current. It's awesome. I want to get one of these eventually. And here it is in all its glory from the back. You're able to add your serial number. So this is actually, I think he said that it's his first amp build ever, and it was successful. So I'm really proud of him on this. You go ahead, Ron, if you're watching, I'm sure you will. Autograph the back, whatever you want to do. Like, that's cool. Serial number 1 for Ron. I think he's indicated that he wants to build more. Very cool. I love this. I sort of, after the rogue or illegal faceplate that I came up with, that's what I settled on as an alternative. Fairfield County Signature by the Tone Geek. It fits in nice. Love the rose. It's kind of a nice touch. Kind of what I was feeling at that time. Is this him playing it? Or that's just part of the bench? I think that's him celebrating the end of it. V Boutique makes great cabs. So it looks like he chose V Boutique, and it fits wonderfully on its side. And then they have the feet right here. I love that. So it looks great, Ron. Congratulations on your build. G1235s, can't beat that. It's a fantastic John Mayer introduction to tone. And that is my Amp Builder Reacts video to Ron's Fairfield County Signature in a Ceriatone JM100 chassis. Stick around and subscribe for more of these and other fascinating things, whatever I'm talking about at that time. Let's do it.